Whenever you're ready, just throw it on the desk for me. Can you all right with that, bud?
Yeah.
Did you guys all get notes over there on that table in the sky here? Perfect. Okay. Guys, JMC updated yesterday. Some double check. See where you're at right now grade-wise. Again, I feel like keep things pretty up to date, but I still have people freak out on me about stuff, even though they know exactly where they are.
Gosh, Parson, why'd you get F?
I'm just joking.
Yeah, things like that just drive me nuts, I guess, Keegan, because
I have a C+.
I know everybody should know where they're at right now. Yeah,
Have you updated like the little page?
Oh, I can do that right now. You want to see where you're at, Gavin? So like the little post-it note you're talking about? Yeah, let me do that quickly for you. Let me throw them up there. We'll do that right now before we start here. Sound good?
I bet we're winning right now.
You think so? We'll see. So you guys were at, let's see, 88%. You guys got a good one going right now. Oh, darn. Went down a little bit, but still very, very good. Well, part of this is because, Sonny's gone, right?
Oh, yeah.
So it's her fault that
Come on, Sunshine.
Wow, class 3. Holy cow.
They go down?
This is pretty impressive right here.
That's so annoying. Make them fail.
Well, I don't want anyone to fail.
Well, you want them to fail if we're not.
I'm not done. I got the next.
I want them to keep that going, and we'll just get some makeup work turned in here. We'll be good. But these guys, I'm telling you, these numbers are phenomenal. I love my numbers here.
Parson, I'm going.
Hey, you're ahead of 5th hour.
I'm leaving at 9:35 to go to the elementary. Are we doing that today?
Yes, Keegan. Is today the first?
Yeah.
That's awesome.
Yeah, I thought it was.
All right, there they are, kids. There they are. You guys got them?
Yep.
Okay, you're still doing great. I love this. Again, 80%. If I get kids achieving at 80% with everything that we do and all the standards that we cover, I'm very, very happy. So you should all give yourself a pat on the back right now because we're doing really good work right now. Okay.
Yeah.
All right, hey, let's start looking at this right here, kids. A little exploration. You guys should have the notes. You guys love the notes, right? Okay. Hey, guys, what shape have we been working with for the most part?
Circle.
We've been working with circles a lot, okay? Just want to do something up here real quickly. Won't be very difficult. Just kind of answer some questions that I have about this. But, kids, I'm going to put up a function here, okay? Here's my function. You ready for it? Okay, let me zoom out here a little bit. Guys, what shape is formed there?
Circle.
Okay. Where's the center appear to be there?
0, 0.
0, 0. Okay. How about a radius value on this? If you think the center's at 0, 0, what's the radius appear to be?
5.
Maybe I'll just go ahead and click on one of these points that intercept the x or y axis. Looks like about 7. Okay, can I change some stuff around? Are you okay with that? Okay, watch this. How about I change 49 to... Is there any connection between 49 and 7?
Yeah.
Huh.
Well, 7 is the square root of 49. 49 is the square of 7.
Okay, let me do this. Any connection there? Where's the center appear to be?
0, 0.
What's it look like the radius is this time?
10.
Is there any connection between the 100 and the 10?
Yeah.
I need to steal a pencil.
There should be plenty up there. You got one?
Yeah.
Okay. So let's make a conjecture. Looks like the radius of this circle is found by doing what?
Squaring.
Square rooting.
Square rooting what value? This constant out here on the end, right?
Yep.
Okay, let me mix this up a little bit for you.
That's not a chunk, that's not a chunk.
That's a pretty neat looking graph, isn't it? You like that?
Scary.
Subtract again.
What shape do I appear to have here?
That's a
Circle.
circle.
Anybody want to guess where the center is?
3,
3 comma what?
0.
So maybe right about here.
Mm-hmm.
3 comma 0. What's this point over here?
Something.
13.
Guys, everything was centered at 0, 0. The thing I changed up here, I put a -3. What direction did that move my circle, basically?
Right.
How many units?
3.
So I would say the center is at 3 comma what?
0.
Okay, let me change this 100 to something that's maybe a little bit better for us. Let's get some even numbers in here. Let's change this to, I'm going to go with a perfect square like 64. If I go with a perfect square like 64, what do you think the radius is going to be?
8.
8, okay. If I leave that -3 in there and I do this with the y's, guys, from the origin, how far right do you think we went? Let me change this to a better value. Let me change this to a better value. Anybody want to guess where the center is for that circle?
1, -2,
No.
Close.
2, -3.
Negative 4.
Getting closer.
1,
Two negative
I'm
four.
going to go in here to make this 0.
2.
So it's kind of the opposite of this, right?
4.
We'll go in here to make this 0. So you guys think the center is at 2, -4? Is that what you're telling me?
Yeah.
Does that blue point look like the center to you guys?
Yep.
Okay, looks like it. What do you guys think the radius for this circle is?
8.
Just count it right here. You guys agree that this point out here is out here on the circle? 10 comma -4. Looks like, and we're counting by 2's on this, right? So from center horizontally out, doesn't that look like 2, 4, 6, 8? Boy, we appreciate that, don't we? Okay, so guys, what we're going to start talking a lot about today in our notes is this: how do circles get formed graphically? We're going to talk about what standard form of a circle looks like. How do you find that center, and how do you find the radius? And then we're going to do some proving or disproving of points upon this circle. Okay. But guys, I think you can kind of visualize what's going on up here with all the numbers or parameters that we changed to move that circle and talk about where's the center and where's the radius. You guys kind of okay with what we talked about just now?
Yes.
Okay, let's see what's in our notes today. First thing we need to understand today, 10.7 is titled Circles in the what? Coordinate plane. So decimals is probably going to help you with some things. How about a volunteer to read my essential question for me?
What is the equation of a circle with center H, K, and radius R on the coordinate plane?
Okay. So our goals today. We're going to write and graph equations of circles. We're going to write coordinate proofs involving circles. We're going to solve some real-life problems using graphs of circles, and we also want to look at solving some nonlinear systems involving circles, okay? So again, all those goals will help us answer the question again in terms of what is the equation of a circle with center, what, comma, what, kids? H, comma, K, and the radius is in the coordinate plane, okay? Guys, we talked yesterday a little bit about completing the square. We'll talk a little more about it as we move forward today in the notes. I have some examples we'll talk about to help us be successful with what we need to do. But guys, I got to be honest with you. Today, vocabulary is important. I think it's really important today. This term right up here. Standard equation of a circle. Right? Standard equation of a circle is given by x minus h quantity squared plus y minus k quantity squared, where r is the what, kids?
The radius.
And
HK
hk is the center. So you're going to see examples kind of like this. You might see an equation, standard form of equation written as x, maybe minus 3 squared plus y plus 2 squared equals 16. Okay, can I ask a question? Where do you think the center is? 3, negative 2, right? They're kind of the opposite of those values. What do you think the radius is going to be? Okay, this is really my r squared out here. 16 is r squared. So if r squared is 16, what would that make just the r value or the radius in this definition?
8.
Not 8. Square root of 16 would be 4. Okay. And then it's completing a square. We're going to talk more about that, but it just simply means to add a constant c to an expression of the form x squared plus bx, so that you have x squared plus bx plus c in perfect square trinomial form. I'm not too worried about that now. We'll look at some examples. Okay? Kids, here's the deal. Core concept. Standard equation of a circle. We pretty much talked about it in the vocab. Okay? It says let x comma y represent any point on a circle. So these points are all the way around here on the circle. With center where, kids? HK is right here. Okay? By the Pythagorean theorem, then, we come up with x minus h squared, this distance, plus y minus k squared, this distance, is equal to the distance in red, r squared. Okay? All this formula ever came from was the Pythagorean theorem. Okay? And you know the Pythagorean theorem already, don't you? Okay? It says this is the standard equation of a circle with center where again, kids? And radius of r. All right? So let's see what we can jump into here today. Guys, the first questions we have is how do I write a standard equation of a circle? Well, kids, in order to write a standard equation of a circle, we must first of all know its center. And we must know the radius next. Okay? Guys, looking at the circle it's graphed in example A, we're trying to write the standard equation of each circle. Where does its center appear to be on this graph, kids?
Negative 5, 5.
So left 5 and up how much?
5.
Boy, is it up 5 or up 4?
4, I said.
I think right here, don't you think, kids? I think that center's left 5. I agree with the negative 5. You okay with that?
Yeah.
But what do you think the height is, kids? Okay. Let's talk about my radius then. What's the radius appear to be if I go from here maybe straight over to here? What's that appear to be, kids? How many units does the radius appear to be in that graph? How much? 4. Okay. So kids, if we're going to write a standard equation of the form x minus h squared plus y minus k squared equals r squared, help me do that here for this example A. We would have x minus the first value listed as h. X minus what? What's the h value for my center? So when I go x minus negative 5, that really turns into what, kids? All to what power? Plus y minus k. So what am I going to have here next? So I'm going to go y minus what? Equals my radius squared. Well, what is the radius again, kids? Radius is, well, we're going to square that 4 to be what here? 16. Okay. Let's just check and see if we're right. I'm going to jump into decimals. What did we come up with again, kids?
X plus 5 squared.
So plus 5, you say? What do we have for the y? Was it y minus 4?
Yep.
And that equaled what radius? I don't know about you kids, but doesn't that circle look like it was at negative 5, 0 here? And then 1 unit away from the x-axis. Doesn't this circle look pretty much the same as what we have right here in our notes. Guys agree? Third quadrant, sorry, second quadrant, okay? Guys, if the center's at the origin, what's h comma k in part B? Okay, so you guys do part B on your own real quickly. See what you come up with, okay? You know the center is where? And you know the radius is how much? Write me an equation that's standard equation of a circle for part B. And then once you think you have it, check with a neighbor around you, see if you agree, okay? Anybody want to take a shot at it today? Anybody think they have it? Don't be shy, guys.
Are they both plus zero?
They could be plus 0, but if I add 0 to anything, is that really going to change it? So can I just call it x to the what right off the bat?
Oh my god.
Yeah, and you know what? If you wrote x plus 0 in there or x minus 0 squared, still okay with that too. So x minus 0 is just going to be what, guys? How about y minus 0? Is that still just going to be what?
Y squared.
Yeah, so if you're ever at the origin, you just start out x squared plus y squared equals... What'd you have to do to the 3.5, kids? And I can't remember what that is. 12 point... Excellent. Now, did anybody have like x minus or plus 0 in the...
Yeah.
And if you did, that's fine. You're still okay with that. But just understand that x plus 0 is just going to be what?
Mrs. Jensen's advisory students, please come to the office this time. Mrs.
0,
Jensen's
right?
advisory students, please come to the office.
It's an identity. So when you add 0, you're just going to have x. How many had the 12.25 out here on the end? Okay. Do you understand this standard form right up here? Really, you know, like this point -5, 4 in the first example, if you have a -5 here, this turns into what sign? Positive. And if you have a positive 4, it's still what? Negative, okay? Grace, this will be online for you. If you want to get the rest of it that way. I'll be sending an online out a little bit later. I would say if you can get a chance to watch it. Keegan, are you in the same boat? If you get a chance to watch the rest of this today and get stuff down, be good. Try to have the peer eval done by the time you get here tomorrow, okay? Sound good?
Yeah.
All right, guys, thanks. Have fun. Okay, let's look at example 2 then. Writing an equation in standard form for a circle. It says the point, what comma what is on the circle, kids? 4, 1 is on the circle with what? 1 comma 4. It says write an equation of standard form for the circle, okay? This one here I'm going to make a note, all right? You might want to visualize this with decimals possibly to help you with this, all right? So here's what I'm going to do, kids. First of all, do we know the center?
Yeah.
Okay, let's do this first. Let's do this. How would you start this out knowing what the center is? I guess maybe the first question is, what is my center? Okay, so the center is what? 1, 4. Okay, so how are you going to start the left side of the equation now for that circle?
Minus 1. Maybe.
So x minus what?
1.
Plus what?
Y minus 1. Or y minus 4.
Yep. Now the only part we need to figure out is what, kids? We need to figure out our radius. Okay, well, I'm just going to jump into decimals and show you this visually quickly, but I think I might be able to give you a shortcut on this if you're okay with that. What do you guys think about that? Okay, here's what I'm going to tell you. You ready? Where's my center at again, kids? Okay. So I have a center at 1, 4, right? Let's punch that in there. 1, 4. There's our center, okay? We know the circle passes through which point, kids? 4, 1. Okay, watch this real quickly. You don't need to write this down. I think I can get you to visualize this, and then we can shortcut this here in a second. Okay, so I'm going to take a picture of this real quickly. So we're saying right here, this is my center. You guys agree with this? And this is a point on the circle. So wouldn't the distance from here to here be your radius, kids? Okay, if I could figure out that radius length, then I could take it to the second power to know the equation, couldn't I? All right, watch this real quickly. What's my, if I would like, look at this in terms of a right triangle. What's the change here going up and down?
1.
Oh, careful. What's the change going here? What do I form there again? So what we would do is we would say 3 squared plus 3 squared is equal to what?
R squared.
What did you say? R squared? Isn't R squared part of our standard equation of a circle? What's 3 squared, kids? 9.
18.
What's 3 squared down here? So R squared must equal what value?
18.
18. R is equal to, I'm just going to say R squared. From this right here, we could say R squared is equal to what value again?
18.
Okay. I want to do something real quickly. Back in my equation. We think R squared is what value? Okay, let me show you the shortcut. We think that this is going to equal what value again? Okay, think of it this way. The center was what point again, kids? And then the point on a circle was, okay, here's how you do this. All you do is you say, all right, what's the change in x's to go from a center to a point on there, kids? How much is that? 3. How much from 4 to 1? How much changes that? 3, you could say negative 3. But to that, what we're going to do is we're going to take both of those changes in distance from a center to a point on a circle. We're going to take both of those changes in distance. In each case, the change in x and the change in y will both what? 3. What you do with the 3 is you square the first 3, you square the second 3. So what are we at? What and what? 9 and 9, add them together. That's your R squared value. Okay? Let's see if we're right, kids. We think this is correct right here, don't we? Let's confirm it. What did we come up with as an equation, kids? Oh, I didn't want to do that. Gosh dang son of a gun. What was that point again? 4, 1? Okay, we want to write a circle that has center 1, 4 and passes through the point 4, 1. We think the equation was, help me out again, x, was it minus 1 first, kids? Squared plus what? Minus 4? Equals how much? How do you guys feel about that? Do you understand the shortcut, I guess, about how to find the radius? If I say, hey, here's the center and here's a point on there, you take the change in x and do what with that?
Find the difference.
Well, we found the difference, and after I found the difference, we square it. Yep. Okay. And then I find the change in y, and we do what with that? Square it. What do I do if the 2 changes squared? Add them together, and that's your R squared on the end. Does that make sense? Listen to this right here. What if my changes in x were 3 and my change in y was 4? What would R squared be? 3 and 4 were the changes. What would R squared be? Say it again. How'd you get 25?
9.
9. I got that, Bank. 9.
That's like higher.
Yes, so 25. I love it. Okay, I love it. All right, kids, we need to touch on this idea about completing the square again, because we can only make this work for us when we were writing equations like this form down here, which is standard equation form of a circle. Okay, so we need to kind of make sure we're okay with this. All right, so let's take a look here. In our notes, guys, complete the square. We talked about this a little bit yesterday. I'm going to blow this up here quickly. What we need to do, kids, is talk about the idea of doing half of b again. So what we want to do is we want to get this to the form of x. Whoops, I didn't want to do that. We want to get this, first of all, you guys talked about completing the square last year. Okay. Secondly, we talked about this a little bit on some of the problems yesterday. I think we did, didn't we? Okay. What we need to do is we need to write these equations of the form x squared plus bx is equal to c first. Okay? So anything with an x stays on the left side. Anything that doesn't have an x goes where, kids? To the right side. Okay. So what would I have to move out of here on the left side? 30. So if I move 30, what would I have to add or subtract 30, kids? Okay, here's what we do. Okay, this is a bad example too. Let's make this 30 just a 3. How's that sound? Actually, no, we'll work. It'll work. It'll work. Don't change it. Don't change it. I think it's going to work. So I'd have to subtract 30. So this would become x squared plus 8x equals what, kids? What's 16 minus 30? Okay. All right. What we do, guys, here to make perfect squares is we focus on the b value. Okay, what is the b value right now? Okay, here's how this works. All right. What we're going to do is we're going to complete that square on the left side. And how this works is as follows. You're going to take the b value and cut it in half. So what's half of 8? 4. Okay, remember that 4 that you just had, okay? What is 4 squared? Okay, take that b value, cut it in half, 4, and square it. Our job is to add 16 to both sides. Okay, we're going to add 16 to both sides, all right? I'm going to just put over here. We took b, divided it by 2, squared it, and then add it to both sides. This is what it means to complete the square, and I'll show you why here. This is going to become the following. It's going to become x squared plus 8x. Guys, what value did you just say to add to both sides? If I add 16 to the right side, negative 14, what's that become? 2. All right? Guys, what we're trying to do is obtain a form on the left such that I can write this as a perfect square. Now, guys, here's the deal. Can you think of a number that is a number in itself that would add to 8 and multiply to 16 at the same time? What was that number? It was 4, wasn't it? Okay? You will always write this now. The left side will become x plus 4 to the second power equals 2. And let me show you why. Up here, and we won't do this on the video, but guys, doesn't x plus 4 squared mean x plus 4 times x plus 4?
Yeah.
Help me do the first. What's x times x? Okay, help me do inside, outside. Outside, wouldn't that be 4x? Inside, wouldn't that be another 4x? So plus how much? And then do last. 4 and 4 would be what? Do you guys agree that this x squared plus 8x plus 16 is x plus 4 times x plus 4? Which is exactly the same as x plus 4 to the what? This is the definition of completing the square. Okay? The first thing we're going to do is get anything with an x on its side to begin with. Anything without an x goes over here. You got that? Then we said take half of which value, kids? B, and do what? Square it and then add it to both sides. You understand the adding of 16 to both sides? Okay, then this becomes x plus whatever value is half of b, or if this was negative, it would be minus down here. But this becomes x plus 4 to the second power is equal to 2. That's what it means to complete the square. Now, what happens if over here I don't have 1x squared. What do you notice is in front of this? What am I going to have to do to everything before I can even start that? You have a question, Leighton?
Yeah, how'd you get 2 from negative 14?
Because over here on the left, did I have a plus 16 in red to get to here?
Okay.
I added 16 to the left, and I also added 16 to negative 14, which became 2 on the right.
Okay.
If I add 16 to the left, I have to do it to the same. You got to keep it balanced, right? Okay, what are you going to do to everything on the right side then to try to complete the square? I just want this of the form 1x squared. But we have how many x squareds up here? So we gosh darn better do what to everything? You better divide everything by 5. Divide 5. Divide 5. Divide 5. Okay, what's 5x squared divided by 5, kids? So we're going to have x squared plus what? 3x, gosh dang it, bad example. That's all right. Plus,
Plus 5.
actually minus 5, right? Equals.
7.
Okay, help me, kids. I want anything with an x on the left and anything without an x on the. We're going to add a 5, so this becomes x squared plus what, kids? 12? Okay, so we're to the point right here where we're going to focus on which value now, kids? What is b right now? What is half of 3? 1.5,
5.
right? So we're going to have to add 1.5 to what power to both sides? Going to have, what is 1.5 squared, kids?
3.
Not 3. Somebody punch 1.5 up to the second power.
2.25.
If I add 2.25 to both sides, 12 will become what, kids? Right? Okay, what was half of that b value, kids? So on the left, you're going to have x plus 1.5 squared. That is this perfect square up here, equal 14.25. Now again, why do we have to know this? Well, I'll show you why, because it's all going to relate back to our standard equation of a circle. But completing the square, kind of with me on it right now? I think the more practice you get with it when we have time, especially in a peer evaluation, I think you'll master it here before you leave today. All right, double check, make sure you have everything down in that example. We need to know how to do that. That's our toolbox to be able to be successful moving forward in the rest of the notes. Guys ready to move on? Okay, next page, kids. So why is this important? Example 3 says graphing a circle. And they start throwing this big mess out here, and it's like, oh my gosh, Parson, I don't know what to do. I'm like, actually, you do know what to do, and here's how it works. Okay. First of all, we have some x's and we have some y's and we have some constants up here. Okay? And what we're going to choose to do is we're going to focus on the x's first. Because again, standard form of an equation or standard form of a circle is going to be x minus h squared plus y minus k squared equals what, kids? Okay. We want to be able to rewrite this in this form right up here. So here's how this is going to work, okay? First thing you're going to do, kids, consider your x's. Okay, step 1. Find your x's. Let's work with the x's, okay? Guys, up here for my x's, what do I have with x's in it? X squared minus what? Okay, x squared minus 2x. Are you with me there? Okay. Let's complete the square on this right here. What's half of negative 2? Negative 1, right? Okay, so here's how we're going to do this. Negative 1, and then what's negative 1 squared? So to complete the square for the x's right here, we are going to add how much? Put this in red. Or now do it this way. We're going to have to add how much to complete this square? 1, right? Okay. Half of negative 2 is negative 1. Negative 1 squared is what? 1. Okay. So what I'm going to do over here, in parentheses, I'm going to write down, we're adding 1 to the x's. Okay. Step 2, if step 1 was the x's, what do you think step 2 is going to be?
Y.
Okay, consider everything with a y in it, kids. Y squared plus what? Let's complete that square. What's half of 6?
3.
3 squared is what? So we're really adding how much more, kids? Okay, watch what happens here. Over here in parentheses, I'm going to say, you know what? We have to add 9 to both sides. Okay? So here's what ends up happening, kids. If I would take everything that we had up here and I would add a 9, and I would add a 1 right here. If I did that to the left side, I'd have to do it also to the what, kids? Okay, so don't worry about that part of it yet, but here's what I want to tell you. Okay, first of all, what the heck, kids, am I going to have to do with this negative 6 to begin with? Do I even want this over here? Does this have a letter with it? I don't even want that here, so eventually that's going where? To the right side. Okay, let's talk here. You guys agree adding 1 and adding 9 complete the squares for both the x's and the what? Okay, so here's how this is going to work. This gets a little tricky. Okay? What was half of this negative 2, kids? So this becomes x minus 1 to what power here after I completed this square? Okay, this and this are exactly the same thing. So the plus 1 is already figured in this right here, right? The plus 1 that we had added here is already figured in this. Okay, what's half of this positive 6 right here, kids? So this really becomes y plus 3 to the second, but the plus 9 is already figured in here. All right? So here's how we're going to do this, kids. Don't these look like parts for the standard equation of a circle? Here's how we're going to do this. We're going to write this, first of all, in standard form. So we're going to say, we call this x minus 1 to what power, kids? Plus the y's, which would be y plus 3 to the second. Now we have to be really careful on a radius, guys. When I take what's right here and what's right here, the plus 1 and the plus 9 are already figured in on the left side. Do we want this minus 6 over here? We're moving it over here. So how much is really on the right side, guys? There's a 6, but what values got figured into the left side in these completing the square values that we need to add to the right side? 1 and 9. So this becomes a 6 over here. What's 6 plus the 1 more I would need to put in on the right? 7, right? Plus 9 more would make the right side what value? Oh my Lord. Looks like by grouping the x's together and completing a square and figuring out what I have to add to the right side, and grouping the y's together, completing a square, and adding the part that got added to complete the square to the right side, gives us this form of an equation that looks like standard form for a circle, doesn't it? Where's the center going to be, guys?
Positive 1.
Positive 1, negative 3. What's the radius going to be? Not 16. Radius will be 4. That out there is r squared, right? Whoa. Alrighty then. Let's graph this puppy. We think the center's where, kids? What's the radius? Yep, it's the square root of 16, which is 4. So let's do our best to draw this. 1, negative 3 is my center, so go right 1 and down how much? Can I show you what I think you should do for drawing circles or sketching them? What did you say the radius was?
4.
Go 4 right, left, up, and down of your center. So go right 1, 2, 3, 4. Go down 1, 2, 3, 4. Go up 1, 2, 3, 4. Go left. And then, as best you can, kids, I would say just sketch a circle in there. I'll try to do my best. I think this is a pretty good sketch right here. Gosh, I drew that pretty well. There it is. You see a mess like this, what do you have to group together first, kids? What are you grouping together first? X's, and then complete the square. Do you understand why I banked these values out to the right here? Because completing the square means, hey, you're adding stuff to the left. If you add stuff to the left, you better add stuff to the... That's going to be a tough concept for you guys, okay? I think, again, it's going to take some work. You're going to have to work to solve it and work hard at figuring that out, okay? All right. Writing a coordinate proof involving a circle. It says prove or disprove with at which point, kids?
At 3.
Okay, prove or disprove that the point 3 root 7 lies on the circle centered where? Containing which point? Okay, so what they're saying here, kids, is this. They're saying in this example, your center is where? Whoops, I don't want that. They're saying your center is where, kids? Centered at the what? And you know that there's a point on there. You know that 1, 4. 1, 4 is a point that's on there. So we could use those 2 points to figure out the radius. So here's the deal. What's the change in x? Okay, and then square that. So 1. What's the change in y's, guys, from center to point? 4? Square 4. What's 1 plus 16 then? So by Pythagorean theorem, the radius would be the square root of what value? Okay. So here's the deal. We know the radius has to be what? So if I want to say, hey, by the way, I know 1, 4 is on there. Is 3, root 7 on there? Well, 3, root 7 is part of the circle. How far away should that point be from the center then? Square root of 17 units, right? So let's see if the radius is the same from the center to one point as it is to the point we're checking. So again, we know our center is where, kids? We want to know, hey, is the point 3, root 7? Is 3, root 7 even on there? I don't know. Let's check. What's the change in x, kids?
3.
Square 3. What do you got? All right, so I'm just going to bank 9 down here. What's the change from 0 up to root 7? Be root 7, wouldn't it? Square root 7, that's just a what? What's 9 plus 7 add up to? So the radius would become the square root of 16. Guys, that's 4. Is the square root of 16 the same as the square root of 17? So is the radius same from the point that we know is the center to the 1, 4 as it is to 3 root 7? Different values. So is 3 root 7 on the circle or not? Nope. The answer is nope. Okay. And the reason is because the 2 radii are different. One's root 17 and one is root 16. Okay? All right, let's see where we're at. How much time we have left? I think I can get one more example out of you, okay? I don't know if I can get the last one out of you. Oh, did I skip example 5?
Yeah.
Oh, no. Okay. No worries. I like this example. We're going to use decimals. This is the last one we'll get to, and then we'll figure out the last one tomorrow, okay? The epicenter of an earthquake is 10 miles away from which point? 2 miles away from, and 5 miles away from. Let's find the coordinates of the epicenter. Now, guys, if there's an earthquake, if I am the earthquake, okay, and I send shock waves out, they go that way, 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 they go that way. They're kind of like going out in what kind of a
Circle.
Okay, well, we want to find the epicenter of this right here, given some points, and we know that the epicenter is how many miles away from this point right here? Okay, 10 miles away from this. Guys, these points are like your H comma K point, and then the 10 miles is like your what? We're going to write some equations for this. And what we're going to do is we're going to say, well, where all three of those circles intersect, that's where that epicenter of the earthquake happens. So let's write some equations because we're going to use what? Okay, help me do the first one. It says the epicenter of an earthquake is what? Okay, so that's center 10 miles, so the radius squared, this is like the radius, and this is like the... Okay, so let's write this. We would say x minus 1 or plus 1? Plus...
Plus 3.
equals the radius squared. What are we using as radius in this first one? So 10 squared would be what? Okay, you guys are going to tell me these here in a second. Okay, next one, kids. It says it's 2 miles away from where? Okay, write me an equation using 5 comma 3, 2 miles away from 5 comma 3. The epicenter is 2 miles away from 5 comma 3. Help me write this equation in. And it's 2 miles away, so 2 squared would be what here? Okay, what's my last equation going to be, kids?
X minus 2 plus y minus 9 squared equals 25.
Plus y minus 9 squared, you said, right?
Yeah.
And equals what value? Y 25? Okay, I want to make sure you guys have that right there first. Do you guys have that first? Are we good there? All right, here's what we're looking at. I'm going to go to decimals, I'm going to graph this. And the epicenter is actually going to be the point where all three of these circles actually do what? Okay, so you guys help me. What was the first equation that we constructed?
X plus 1 squared plus y plus 3 squared equals 100.
Okay, so we've got that first one. What was the next one?
X minus 5 squared.
Okay, plus...
Y minus 3 squared equals 4.
And then my last one.
X minus 2 squared. Y minus 9 squared equals 25.
Oh, shoot. Hang on a second. Got a mistake in here. Minus 9
Yeah,
equals how much again?
25.
Guys, do you see a point where all three of the circles intersect at?
Yes.
Where?
Right there.
The epicenter of this earthquake happened where? Actually, you got to be all three. So where does the blue and the green and the purple intersect each other? 5 comma 5. So if this whole map was gridded out right here, we would say, well, that earthquake, the epicenter of that earthquake happened at what point? Okay. 5 comma 5. All right, I'm going to stop.